Hello, my name is David Mahalik. I'm an engineer here at Fort Defiance Industries. We're talking about the P2131 sterilizer, and in this video, we're going to talk about reading the electrical diagram. So, we're just going to talk about a few of the things unique to our electrical diagram, and the rest of it will help you just troubleshoot any electrical problems you may have. So, kind of the layout here. Up here on the left, we have the sterilizer main unit. All the 120 and 208 voltage on the sterilizer main unit. Down here we have the water recovery system, and it's connected by that cable. When you set up the water recovery system, connect the power from the sterilizer main unit to the water recovery system, you're connecting that cable. Over here on the right we have all the 24 volts. So we have the PLC right here with all the inputs and outputs. We have the RTD transmitters down here on the right. So going back here over on the left, if you can zoom in and see one of these wire numbers, we'll talk about that. On the left side, you have the line number. So on the left side I have 16 over here, so if I go over to this number, the number is 161-V. So it's line 16. It's the first wire on that line, and it's -V because it's V for violet. So all these little wires have a wiring number, and BL is for blue. So if it's -VL, it's blue. If it's -W/B, it's a white/blue. It's a typically going to be a neutral wire for your DC voltage. If you have -V, B is for black, -O, O for orange, -R, R for red, and -G, G for green, which is going to be all your grounds. Now, if there's no number after the letter, that means it's a 16 gauge wire. So this 161-V, it's a 16 gauge wire. Throughout the rest of the electrical schematic, you'll see sometimes there's a number after. So if we can come up here, this orange 26-B10. So it's a black wire and it's 10 gauge. So you'll see a lot of those. If there's a 10, you know it's 10 gauge wire. If there's no number after the letter, then it's 16 gauge wire. So again, you can just use this whole electrical schematic to troubleshoot your electrical problems. We got our 24 volt power on the right, the PLC, the transmitters. We got all the water recovery system down here, and then we have the sterilizer main unit right here. I want to give you a few examples of how to use this electrical schematic to troubleshoot. So I'm going to give you two examples. In the first one, suppose that our sterilized valve is not operating. We can pull up our electrical wiring diagram in the technical manual, and so what you're going to want to do is you're going to want to find the sterilized valve. So up here on the left, in the sterilizer main unit area, right here, I can see the solid state relay 1 and 2, and then I can see that here's the actual sterilized valve right here. So in order for it to get power, the 24 volts across the bottom of the relay has to close. So if I go over here to the PLC and I find solid state relay 1 right here, I can see that it's output 2. So, maybe you have some wiring issues there. There's a loose wire. You could check that, but you'll know that there should be a wire going from output 2 to terminal 3 on solid state relay 1, and then you'll have a wire going to terminal board 1-8. So you can kind of check some of that stuff. You can use your multimeter to check voltages there. But during a cycle, when the PLC needs to open the sterilized valve, it'll send 24 volts out this output. It'll complete the circuit of solid state relay 1. And then if we go over here, when terminals 3 and 4 have power across it, it closes the top 1 and 2, So once this is closed, and it's normally open, but once it's closed, it'll send power to the sterilize valve and open it. So you could also have some maybe wiring issues over here. If you knew you were getting 24 volts, but you weren't getting continuity across this, you would know that the solid state relay is possibly malfunctioning, is broken, and you would need to replace it. So what you could also do is come over here, and you would see that in order for power to get over here, fuse block 2-1, the slow blow fuse, is going to have to be intact, so you can check that fuse even. So it's kind of an example of how you could use this to troubleshoot. For example number 2, we're going to talk about the heaters. So up here, we have our 3 resistance heaters. You can see them H1, H2, H3. If we come over here a little bit, we can see solid state relay 6, 7, and 8. So those are the relays that are firing the heaters. So whenever these relays have 24 volts across the bottom of them, it will close this. Voltage will be able to flow to the heaters, and it'll turn the heaters on and off. So you could check for continuity across those. If you come down here, I can see that the output of the PLC, solid state relay 6, 7, and 8, I can see the wire numbers that go to the terminals. They're all 3s on the input of the solid state relays and 4s on the output. But you can check all these wires, and I know when the PLC wants to fire a heater, it'll send 24 volts to these relays, close them, then the heaters will turn on. So that's the second example of how to use this electrical line diagram. You can use it very similarly for any other problems you have. You can locate the relay, you can locate the switch, you can locate the heaters, and you can follow all the wires which match the electrical enclosure and troubleshoot your electrical problems. And that's it for the electrical line diagram.